And now in this lecture we'll answer on two questions. In the first question we'll find out the radius of this quarter circle. In the second question we'll find out the size of this angle theta, that is inside triangle ABC. So we'll start with the first question. In the drawing we have a quarter circle. Side line segment BC equals to 9 units, line segment CD equals to 16 units, and line segment EL equals to 12 units. This angle OBC equals to 90 degrees, angle BCD, this angle equals to 90 degrees, and this angle CDL, it is also equals to 90 degrees. And our mission is to find out the radius of this quarter circle. Okay, so because of the fact that this is a quarter circle, we can conclude from it that point O is the center of the quarter circle, so I write it down. Point O is the center of the quarter circle. This is the first thing. In addition, we can conclude from the fact that this is a quarter circle that this angle BOF, it is equal to 90 degrees, it is a right angle. And finally, here side AO equals to side OF, and both sides are the radii of this quarter circle. And if we define the radius of this quarter circle as R, then OA will be equal to R, and OF will be also equal to R. Both those sides are the radii of this quarter circle. So both of them are equal to R. Okay, so in the next step, we will extend the straight line CD by a straight line until it intersects with the radius OF of the quarter circle. And we will define the touching point of the extended straight line CD and OF as point M. So here, by doing this construction, we created here quadrilateral BCOM. In quadrilateral BCOM, we have 1, 2, 3 right angles. I repeat again, in the quadrilateral BCOM, we have 1, 2, 3 right angles. And the sum of 3 right angles is 90 times 3 is 270 degrees, plus the size of the fourth angle, that is actually angle DMO. In total, the sum of those 4 angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. So here we will subtract 270 degrees from this equation, and we get that the missing angle DMO is equal to 360 degrees minus 270 degrees, it is equal to 90 degrees, it is a right angle. So this angle DMO, it is a right angle, it is equal to 90 degrees. So actually we found out that in quadrilateral BCOM we have 4 right angles. And any quadrilateral that has 4 right angles must be at least a rectangle if not a square. So we will relate quadrilateral BCOM as a rectangle. Quadrilateral BCOM is a rectangle because it has 4 right angles. Okay? Repeat again. Quadrilateral BCOM is a rectangle. And we know that the opposite sides of a rectangle are equal to each other. Therefore, here in rectangle BCOM, side BC must be equal to side OM. So BC equals to OM. According to the rule that the opposite sides of a rectangle are equal to each other. But according to what is given us in the question, BC equals to 9 units. So we can write here that BC equals to 9. And from this equation, 9 equals to BC equals to OM. We will derive that OM is also equals to 9 units. Here OM equals to 9 units. So I can write here that OM equals to 9 units. Here it is given us the question that CD, line segment CD is a straight line, and we actually extended the straight line CD by a straight line. When you extend a straight line by a straight line, the result must be a straight line. Okay, so therefore the result of extending the straight line CD is line segment CM, therefore CM must be a straight line. So I'm writing down CM is a straight line. Okay, CM is a straight line. Yeah. CM is a straight line. And we have rule number 3 that states that the sum of the angles on one side of a straight line is equal to 180 degrees. Here we have the straight line CD. So if we focus on the upper side of the straight line CD at point O, here the sum of the angles must be equal to 180 degrees. Which angles we have on the upper side of CD at point O? We have here alpha plus beta. So alpha plus beta must be equal to 180 degrees according to rule number 3. We can implement rule number 3 in our drawing, because in our drawing we have the straight line CM. So if we focus on this side of the straight line CM at point D, here the sum of the angles must be equal to 180 degrees according to rule number 3. So which angles we have at this side of CM at point D? We have this angle that is equal to 90 degrees plus this angle that is actually angle LDM. In total, the sum of those two angles must be equal to 180 degrees. I repeat again, 90 degrees plus angle LDM must be equal to 180 degrees according to rule number 3, of course. Here we will subtract 90 degrees from this equation, and we will get that the missing angle LDM is equal to 180 degrees minus 90 degrees. It is equal to 90 degrees. So the missing angle is a right angle. So this angle equals to 90 degrees. It is a right angle. Likewise, OF is the radius of the quarter circle, therefore it is absolutely a straight line. So we can write down that line segment OF is a straight line repeat again. Line segment OF is a straight line. So if we focus on the upper side of the straight line OF at point M, here the sum of the angles must be equal to 180 degrees according to rule number 3. So which angles we have at the upper side of OF at point M? We have this angle that is equal to 90 degrees plus this angle that is actually angle DMF. In total, the sum of those two angles must be equal to 180 degrees according to rule number 3. Okay. So here we will subtract 90 degrees from this equation and we get that the missing angle, angle DMF, is equal to 180 degrees minus 90 degrees, it is equal to 90 degrees. Okay, actually this angle is the right angle, it is equal to 90 degrees, angle DMF. In the next step, we will do a construction from point L. We will draw a perpendicular on the radius OF of the quarter circle. Here, from point L, we draw perpendicular on the radius OF of the quarter circle. And we define the touching point of the perpendicular from point L and OF as point N. Point N is the touching point of the perpendicular from point L and OF. Okay. Here actually from point L we draw the perpendicular on OF, therefore this angle equals to 90 degrees according to our construction. Okay. So by doing this construction, we created here quadrilateral LDMN. In quadrilateral LDMN, we have 1, 2, 3 right angles. And the sum of 3 right angles is 90 times 3 is 270 degrees, plus the size of the fourth angle that is actually angle DLN. In total, the sum of those 4 angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Okay, so here we subtract 270 degrees from this equation, and we get that the missing angle, angle DLN, is equal to 360 degrees minus 270 degrees, it is equal to 90 degrees, so it is a right angle. This angle, it is a right angle, it is equal to 90 degrees. So actually we found out that inside quadrilateral DLMN, we have 4 right angles. And any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. So we will relate to quadrilateral DLMN as a rectangle because it has 4 right angles. So quadrilateral DLMN is a rectangle. Okay. And repeat again. Quadrilateral TLMN is a rectangle. We also know that the opposite sides of a rectangle are equal to each other. So the opposite sides of rectangle DLMN must be equal to each other. That is to say, DL must be equal to MN. DL must be equal to MN. Repeat again. DL must be equal to MN according to the rule that the opposite sides of rectangle are equal to each other. But here DL equals to 12 units according to what is given as the question. So we can write here that DL equals to 12. And from this equation 12 equals to DL equals to MN, we will derive that MN is also equals to 12 units. Okay, MN equals to 12 units. Here we can write down that MN equals to 12 units. So here actually ON equals to 9 plus 12, that is 21 units. And because of the fact that point F is very close to point N, here point F is very close to point N, it means that the radius OF must be very close to the value of 21 units, that is the length of line segment OM. So we are expecting to the value of the radius that it will be a little bit longer than 21 units, that is the length of line segment OM. So in the next step, we join point C and O together, but before that, according to the same rule that the opposite sides of a rectangle are equal to each other, DM equals to LF. But before that, we define DM as H. Here DM equals to H according to our definition. And we have the same rule that the opposite sides of a rectangle are equal to each other. That is to say, side DM equals to side LN. DM equals to LN. Again, rectangle DM and N, side DM must be equal to side LN. But according to our definition, side DM equals to H. DM equals to H. So from this equation, H equals to DM equals to LN, we will derive that side LN is also equals to H. LN equals to H. LN equals to H. Okay. So in the next step, we will join point C and O together by a straight line. Point O is the center of the quarter circle. Point C is the point of the quarter circle itself. And this is exactly the definition of a radius. That is to say, OC is the radius of the quarter circle that is equal to capital R according to our definition. In the next step, we will implement the Pythagoras theorem on the right green triangle OMN. In the right green triangle OMN, according to the Pythagoras theorem, here by PT is abbreviation for Pythagoras theorem. So according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in the green right triangle is OC, therefore the square of the hypotenuse is OC square, and it must be equal to the sum of the squares of the perpendiculars, that is to say, it must be equal to OM square plus CM square. I repeat again, in the right main triangle, triangle OMN, according to the Pythagoras theorem, OC square equals to OM square plus CM square. So here, OC equals to R, therefore OC square is R square, and it is equal to OM square. OM equals to 9, therefore OM square is 9 square, that is 81. Plus CM square. CM equals to CD plus DM. That is to say, CM equals to CD, that is 16, plus DM, that is H. So in total, CM equals to 16 plus H. CM equals to 16 plus H. Therefore, CM square equals to 16 plus H square. So, in conclusion, it's found out that according to equation number 1, R square equals to 81 plus 16 plus H square. Here, we will open the brackets on this side of equation number 1, and we will get that according to equation number 1, R square equals to 81 plus 16 plus H square. 16 plus H square, 16 plus H square equals to 16 square, that is 256, plus H square plus 2 times 16, that is 32, and 32 times H is 32H. Okay, so here we found out that according to equation number 1, R square equals to 81 plus 256 is 337, plus H square plus 32H. So according to equation number 1, R square equals to 337 plus H square plus 32H. In the next step, we will join points O and L together by a straight line. Point O is the center of the quarter circle. Point L is the point of the quarter circle itself. This is exactly the definition of a radius. That is to say, OL is the radius of the quarter circle, that is equal to R. In the next step, we will implement the Pythagoras theorem on the orange right triangle, triangle LNO. So in triangle LNO, according to the Pythagoras theorem, by PT is the version for Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is OL, therefore the square of the hypotenuse is OL square. And it must be equal to the sum of the squares of the perpendiculars, that is to say, it must be equal to LN square plus ON square. I repeat again. In the right orange triangle, triangle OLN, according to the Pythagoras theorem, OL square equals to LN square plus ON square. Okay. OL is the radius of the quarter circle, that is equal to R, therefore OL square equals to R square. and it is equal to ln square. ln equals to h, therefore ln square is h square plus on square. On equals to om plus mn. That is to say on equals to om, that is 9, plus mn, that is 12. And 9 plus 12 is 21. So in conclusion, on equals to 21, therefore on square will be equal to 21 square. So according to equation number 2, we found out that r square equals to h square plus 21 square. 21 square is 441, so I write it down. We found out that r square equals to h square plus 441. So actually here we have two different expressions for r square. Therefore we will create equation number 3 that states that r square according to equation number 1 must be equal to r square according to equation number 2. Okay. And r square according to equation number 1 is 337 plus h square plus 32h, and it must be equal to r square according to equation number 2, that is actually equals to h square plus 441. Okay, so here we have h square on both sides of equation number 3, so h square will get cancelled. What is left from equation number 3 after we cancelled h square? What is left is actually in this side of the equation we have 337 plus 32h, that is equal to 441. Here we subtract 337 from this equation number 3, and we get that according to equation number 3, h equals to 441 minus 337, it is equal to 104. So in conclusion, we found out that according to equation number 3, 32h equals to 104. Here we divide this equation number 3 by 32, and we'll get that according to equation number 3, h equals to 104 over 32. So we found out that h equals to 104 over 32, that is 3.25 units. So you can write here that h equals to 3.25 units. Now we can substitute h in equation number 2 by 3.25 units. So according to equation number 2, r square equals to h square plus 441. So r square equals to h square. h equals to 3.25 units, therefore h square will be equal to 3.25 squared, that is 10.5625 plus 441. So we found out that r square, according to equation number 2, r square equals to 441 plus 10.5625, it is equal to 451.5625. So here we take a root out of this equation number 2, and we find out that the radius of the quarter circle is equal to r equals to the square root of 451.5625. That is to say, it is equal to the square root of 451.5625. It is equal to 21.25 units. Okay, I repeat again. The radius of the quarter circle R equals to 21.25 units. Okay, and we actually got result that is according to our expectations. ON equals to 21 units and the radius OF equals to 21.25 units. That is to say, the radius of this quarter circle is greater in 0.25 units from line segment ON, that is equal to 21 units. So we finished with the first question. Here R equals to 21.25 units. So we finished with the first question. In the next step, I will present to you the second question, and we will solve the second question in two different methods. So here in the drawing we have triangle ABC. Side AB equals to x plus y units, side AC equals to y units, this angle equals to 40 degrees, this angle ADC equals to 80 degrees, and our mission is to find out the size of this angle theta. So in the first method we'll do a construction. We will extend the side BC in y units. Okay. We'll extend side BC by straight line in y units. We define this point E. Line segment CE equals to y units according to our construction. In the next step, we'll join points A and D together by a straight line. So here we created triangle ACE. I will copy triangle ACE in a new page and we will analyze triangle ACE. Okay. So this is triangle ACE that I copied from the original drawing. Side AC equals to y according to what is given as the question, and side CE equals to y units according to our construction. Okay, and so those two sides are both equal to y, therefore they are equal to each other. So here we can write down that side AC equals to side AE, they are both equal to y, therefore they are equal to each other. And we have the rule that in front of equal sides in the triangle there are equal angles. So here in front of this side we have angle CAE, this angle. While in front of this side we have angle AEC. And according to the rule that I mentioned, this angle, those two angles must be equal to each other. Why? Because they are located in front of equal sides. So angle CAE equals to angle AEC. So if we define angle AEC as alpha, here angle AEC equals to alpha, then from this equation angle CAE equals to angle AEC equals to alpha, we will derive that angle CAE is also equals to alpha. This angle CAE equals to alpha. Okay, so those two angles are equal to each other. And here I will copy angle ACB in here, and we know that angle ACB equals to 40 degrees according to what is given us the question. So this is angle ACB. That is equal to 40 degrees according to what is given as the question. In the next step, I will present to you the exterior angle theorem, and we will implement the exterior angle theorem in our triangle ACE. So what is the exterior angle theorem? The exterior angle theorem is true in any triangle, so here we have triangle ABC that could be any triangle. This is triangle ABC. In triangle ABC, this angle equals to alpha, this angle equals to beta, and this angle equals to gamma. Here angles alpha, beta, and gamma are defined as interior angles because they are located inside triangle ABC. While this angle ACD, angle ACD, this angle is defined as an exterior angle. So we'll define the exterior angle ACD as E. I'll write it down that angle E is defined as an exterior angle. Why? Because it is located outside triangle ABC. Therefore, it is defined as an exterior angle. So we have here three interior angles, alpha, beta, and gamma, and one exterior angle, angle ACD. It is equal to E. So actually, the exterior angle theorem gives us the size of the exterior angle angle E. What is the size of the exterior angle E? According to the exterior angle theorem, the size of the exterior angle E will be equal to the sum of the two interior angles that are not adjacent to it. This angle gamma is adjacent to angle E, and the other two interior angles that are not adjacent to angle E are alpha and beta, and the sum of those two angles, alpha and beta, is alpha plus beta. That is to say, this, the size of the interior angle ACD that is equal to E is equal to alpha plus beta, that is the sum of the two interior angles that are not adjacent to the exterior angle E. Okay, E equals to alpha plus beta. Now we will implement the exterior angle theorem in our triangle ACE. Those two angles are located inside triangle ACE, therefore they will be defined as an interior angles. While this angle ACB is located outside triangle ACE, therefore it will be defined as an exterior angle in relation to triangle ACE. Angle ACB is defined as an exterior angle. So what is the size of the exterior angle ACB? The size of the exterior angle ACB, according to the exterior angle theorem, it will be equal to the sum of the two interior angles that are not adjacent to it. Here this angle ACE is adjacent to angle ACB, therefore it is not good here. We take the two other interior angles that are not adjacent to it, that are alpha and alpha. So the sum of those two angles is alpha plus alpha. So we actually found out that the size of the exterior angle ACB, it is equal to alpha plus alpha, according to the exterior angle theorem. But it is given as the equation that is equal to 40 degrees. So we can write here that angle ACB equals to 40 degrees. And from this long equation, here alpha plus alpha equals to 2 alpha. So from this long equation, 40 degrees equals to angle ACB equals to alpha plus alpha equals to 2 alpha. We will derive that 40 degrees equals to 2 alpha. Here we will divide this equation by 2, and we get that the angle alpha equals to 40 degrees over 2 is 20 degrees. Okay, we found out that angle alpha equals to 20 degrees. So angle CAE, this angle CAE equals to alpha, and alpha equals to 20 degrees, and also angle AEC equals to alpha, that is equal to 20 degrees. Okay. In the next step, we will focus on triangle ADC. This angle equals to 80 degrees. This angle equals to 40 degrees. The sum of those two angles is 40 degrees plus 80 degrees is 120 degrees. So the third angle of triangle ADC must be equal to 60 degrees. Why? Because 60 degrees plus 120 degrees is equal to 180 degrees, and that is the sum of the angles in any triangle. Okay, so this angle must be equal to 60 degrees. Okay, in the next step, I will copy triangle ADE in a new page, and we will analyze triangle ADE. angle DAE, this angle equals to 60 degrees plus 20 degrees, that is 80 degrees. This angle equals to 80 degrees according to what is given as the question. What is the size of line segment DC or side DE? Side DE equals to DC plus CE. That is to say, DE equals to DC, that is X, plus CE, that is Y. So in total, DE equals to X plus Y. Okay. So this is triangle ADE that I copied from the original drawing. In triangle ADE, those two angles are both equal to 80 degrees, therefore they are equal to each other. And we have the rule that in front of equal angles in the triangle, they are equal sides. So in front of this angle, we have side DE. I'll write it down. And in front of this angle, we have side AE. And according to the rule that I mentioned, those two sides are equal to each other because they are located in front of equal angles, therefore they are equal to each other. So we found out that DE equals to AE, but according to what we have already found out, that DE equals to X plus Y. So actually, from this equation, X plus Y equals to DE equals to AE, we will derive that AE is also equals to X plus Y. AE equals to X plus Y. In the next step, I will copy triangle ABE, the big triangle ABE, in this page, and we will analyze triangle ABE. Side AB equals to X plus Y according to what is given as the question. This angle equals to theta according to what is given as the question. This angle equals to 20 degrees according to what we have already found out. And we just right now found out that side AE equals to X plus Y, so I write it down. So this is triangle ABE that I copied from the original drawing. In triangle ABE, those two sides are both equal to X plus Y, therefore they are equal to each other. Okay, so I'll write it down. Side AB equals to side AE. Both sides are equal to X plus Y, therefore they are equal to each other. Actually, because of the fact that those two sides are equal to each other, we can say that triangle ABE is an isosceles triangle. So we have those two sides are equal to each other in triangle ABE, AB equals to AE, and we have the rule that in front of equal sides in the triangle there are equal angles. That is to say, in front of this side, side AE, we have angle theta, and in front of this side, side AB, we have this angle that is equal to 20 degrees. And according to the rule that I mentioned, that in front of equal sides in the triangle there are equal angles, those two angles must be equal to each other because they are located in front of equal sides. That is to say, angle theta equals to 20 degrees. So I found out that the size of angle theta, the angle that we are looking for, it is equal to 20 degrees. So we finished with the first method. In the next step, I present to you the second method. In the second method, we'll focus on triangle ADC. In triangle ADC, this angle equals to 80 degrees, this angle equals to 40 degrees. 80 degrees plus 40 degrees is 120 degrees. So the sum of those two angles in triangle ADC is equal to 120 degrees. Therefore, the third angle must be equal to 60 degrees, because 60 degrees plus 120 degrees is 180 degrees. And the sum of the angles in any triangle must be equal to 180 degrees, therefore this angle must be equal to 60 degrees. Okay? And you can also find out the size of this angle. ABC is a triangle, therefore BC is one side of triangle ABC, therefore it is absolutely a straight line. So if you focus on the upper side of the straight line BC at point D, here the sum of the angles must be equal to 180 degrees. So which angles we have at the upper side of BC at point D? We have this angle that is equal to 80 degrees, plus this angle that is angle ADB. In total, the sum of those two angles must be equal to 180 degrees. And because of the fact that this angle equals to 80 degrees, this angle must be equal to 100 degrees in order to complete the sum of the angles in the upper side of the straight line BC at point D to 180 degrees. This angle must be equal to 100 degrees. Okay? So, in the next step, we'll define side AD as A, and I'll present to you the law of sines, and we will implement the law of sines in our triangles. So what is the law of sines? The law of sines is true in any triangle. So here we have triangle ABC that could be any triangle. This is triangle ABC. Side BC of triangle ABC equals to A units in its length. Angle BAC equals to capital A degrees in its size. Side AC equals to B units in its length. And angle ABC equals to capital B degrees in its size. And finally, we define side AB as C, that is to say AB equals to 3 units in its length, and angle ACB equals to capital C degrees in its size. So here, according to the law of sines, we get that A over sine A is equal to B over sine B, and it is equal to C over sine C. I repeat again, according to the law of sines, in this triangle ABC, A over sine A equals to B over sine B equals to C over sine C. Now we will implement this law, the law of sines, in triangle ADC, in the green triangle ADC, according to the law of sines. We will get that in triangle ADC, according to the law of sines, we get that DC DC over sinus 60 degrees equals to AD over sinus 40 degrees and it is equal to AC over sinus 60 over sinus 80 degrees. AC over sinus 80 degrees. So here, equation number 1 is the implementation of the law of sines in this triangle, the green triangle ADC. AD equals to A, so it's, no, here we have DC equals to X, so we substitute DC by X and we get that X over sinus 60 degrees equals to AD. AD equals to A, so we substitute AD by A and we get A over sinus 40 degrees. And it is equal to AC equals to Y, so we substitute AC by Y, so it is AC over sinus 80 degrees. Okay, so we have here three expressions that are all equal to each other, so we can define them as that they are all equal to K. Because of the fact that they are all equal to each other, we can define them as that they are all equal to K. And then we will derive the first equation from this long equation. Those two expressions are equal to each other, that is to say, according to equation number 1, X over sinus 60 degrees equals to K. Here we will multiply this equation number 1, by sinus 60 degrees, and we'll get that according to equation number 1, X equals to K times sinus 60 degrees. Okay, we'll derive the second equation from this long equation. Those two expressions are equal to each other. This expression equals to k. So here, according to equation number 2, we'll get that a over sinus 40 degrees equals to k. Here we'll multiply this equation number 2 by sinus 40 degrees, and we get that according to equation number 2, a equals to k times sinus 40 degrees. And finally, those two expressions are also equal to each other. That is to say, this will be equation number 3. Only to equation number 3, y over sinus 80 degrees equals to k. Okay. Here we multiply this equation number 3 by sinus 80 degrees, and we get that according to equation number 3, y equals to k times sinus 80 degrees. We actually found out the values of x, y, and a. Okay. In the next step, we will implement the law of sines in this triangle ABD. So we'll implement the law of sines in the orange triangle ABD. So in the orange triangle ABD, according to the law of sines, AD over sinus theta equals to AB over sinus 100 degrees. AB over sinus 100 degrees. So equation number 2 is the implementation of the law of sines in the orange triangle ABD. Okay, AD over sinus theta equals to AB over sinus 100 degrees. We'll substitute AD by A. So it is A over sinus theta that is equal to AB. AB is equal to x plus y, so we'll substitute AB by x plus y. That is AB over sinus 100 degrees. So in conclusion, I found out that according to equation number 2, A over sinus theta equals to x plus y over sinus 100 degrees. We've already found out that A equals to k times sinus 40 degrees, so we substitute A by k times sinus 40 degrees over sinus theta and it is equal to x plus y. We already found out that x equals to k times sinus 60 degrees, and we already found out that y equals to k times sinus 80 degrees here. So we'll substitute y by k times sinus 80 degrees, all divided by sinus 100 degrees. Okay. Here we have k on both sides of the equation number 2, so k will get cancelled. What is left from equation number 2 after we cancelled k? Here in this side of the equation we left with sinus 40 degrees over sinus theta that is equal to sinus 60 degrees plus sinus 80 degrees over sinus 100 degrees. Okay. Here we will cross multiply this equation, equation number 2, and we get that according to equation number 2, sinus 40 degrees times sinus 100 degrees equals to sinus theta times sinus 80 degrees times sinus 80 degrees plus sinus 60 degrees. So here we will divide this equation, equation number 2, by sinus 80 degrees plus sinus 60 degrees, and we get that according to equation number 2, sinus theta equals to sinus 40 degrees times sinus 100 degrees over sinus 80 degrees plus sinus 60 degrees. Okay. Here I will present the first trigonometric identity, that sinus 2a equals to 2 times sinus a times cosine a. Okay. We'll use this trigonometric identity in order to find the value of sinus 40 degrees. Sinus 40 degrees is equal to sinus 2 times 20 degrees, and according to this trigonometric identity, sinus 2a equals to 2 sine a cosine a, we get that sinus 2 times 20 degrees equals to 2 times sinus 20 degrees times cosine 20 degrees. So in conclusion, we found out that sinus 40 degrees equals to 2 times sinus 20 degrees times cosine 20 degrees. Okay. In the next step, I will present to you the second trigonometric identity, that sinus 90 degrees plus theta equals to cosine theta. And we'll use this trigonometric identity for sinus 100 degrees that we have in equation number 2 here. So sinus 100 degrees equals to sinus 90 degrees plus 10 degrees, and according to this trigonometric identity, that sinus 90 degrees plus theta equals to cosine theta, we get that sinus 90 degrees plus 10 degrees equals to cosine 10 degrees. So in conclusion, we found out that sinus 100 degrees equals to cosine 10 degrees. Now we can substitute cosine sinus 100 degrees for cosine 10 degrees in equation number 2 here, and we will also substitute sinus 40 degrees by 2 times sinus 20 degrees times cosine 20 degrees in equation number 2, and we get that according to equation number 2, sinus theta equals to sinus 40 degrees, but we already found out that sinus 40 degrees equals to 2 times sinus 20 degrees times cosine 20 degrees. And we have to multiply it, according to equation number 2, by sinus 100 degrees, but we already found out that sinus 100 degrees equals to cosine 10 degrees. Okay, and all divided by sinus 80 degrees plus sinus 60 degrees. Here I present to you the trigonometric identity that sinus D plus sinus C equals to 2 times sinus D plus C over 2 times cosine D minus C over 2. We'll use this trigonometric identity in order to find the value of sinus 80 degrees plus sinus 60 degrees. Here. So sinus 80 degrees plus sinus 60 degrees will be equal, according to this trigonometric identity, to 2 times sinus D plus C. D is 80, C is 60, so 80 degrees plus 60 degrees is 140 degrees, and 140 degrees over 2 is 70 degrees. Times cosine D minus C. D is 80, C is 60, so 80 minus 60 is 20, and 20 over 2 is 10. So in conclusion, I found out that sinus 80 degrees plus sinus 60 degrees equals to 2 times sinus 70 degrees times cosine 10 degrees. Therefore, we substitute sinus 80 degrees plus sinus 60 degrees in equation number 2 by 2 times sinus 70 degrees times cosine 10 degrees. We will do it now. We will get that according to equation number 2, sinus theta equals to 2 times sinus 20 degrees times cosine 20 degrees times cosine 10 degrees And in the denominator we have sinus 80 degrees plus sinus 60 degrees in equation number 2, so we substitute sinus 80 degrees plus sinus 60 degrees by 2 times sinus 70 degrees times cosine 10 degrees. Okay, so here we have cosine 10 degrees in the numerator, we have cosine 10 degrees in the denominator, so cosine 10 degrees will get cancelled. We have 2 in the numerator, we have 2 in the denominator, so 2 also will get cancelled. What is left from equation number 2 after we cancel those two expressions? What is left? Actually, we have here in this side of the equation we have sinus theta that is equal to sinus 20 degrees times cosine 20 degrees over sine 70 degrees. In the next step, I will present to you the last trigonometric identity, and we use the trigonometric identity for sinus 70 degrees. The trigonometric identity states that sinus 90 degrees minus theta equals to cosine theta. Okay, sinus 90 degrees minus theta equals to cosine theta, and we have we know that sinus 70 degrees equals to sinus 90 degrees minus 20 degrees, and sinus 90 degrees minus 20 degrees, according to this trigonometric identity, that sinus 90 degrees minus theta equals to theta will be equal to cosine 20 degrees. So in conclusion, we found out that sinus 70 degrees equals to cosine 20 degrees. Therefore, we'll substitute sinus 70 degrees in the denominator of equation number 2 by cosine 20 degrees, and we will get that according to equation number 2, sinus theta equals to sinus 20 degrees times cosine 20 degrees over sinus 70 degrees, but we have already found out that sinus 70 degrees is equal to cosine 20 degrees, therefore we substitute sinus 70 degrees in the denominator of equation number 2 by cosine 20 degrees. Okay? So here we have cosine 20 degrees in the numerator, and we have cosine 20 degrees in the denominator, so cosine 20 degrees will get cancelled, and we left only with sinus theta that is equal to sinus 20 degrees. And we have the trigonometric identity that states that if sinus alpha equals to sinus beta, it means that alpha equals to beta. So according to this trigonometric identity, we will get that if sinus theta equals to sinus 20 degrees, it means that theta equals to 20 degrees. So we found out that the size of angle theta is equal to 20 degrees according to the second method also. In the next step, I will summarize the lecture. We'll start with the first question. In the drawing, we have a quarter circle You know that line segment AC equals to 9 units, line segment CD equals to 16 units, line segment DL equals to 12 units. This angle equals to 90 degrees, angle BCD also equals to 90 degrees, and angle CDL also equals to 90 degrees. And our mission is to find out the radius of this quarter circle. So, because of the fact that this is a quarter circle, here this point O must be the center of the quarter circle. Point O is the center of the quarter circle. This angle BOF equals to 90 degrees, and side AO must be equal to side OF, and both sides are defined as the radii of this quarter circle. So we define the radii of the quarter circle as R. Therefore, both those two sides, side AO and side OF will be equal to R. That is the radius of the quarter circle. Okay, in the next step, we extended the straight line CD by a straight line until it intersects with the radius OF of the quarter circle. We define the touching point of the extended CD and OF as point M. So by doing this construction, we created here quadrilateral BCOM. Inside quadrilateral BCOM, we have 1, 2, 3 right angles. Okay, I'll repeat again. Inside quadrilateral BCOM, we have 3 right angles, and the sum of 3 right angles is 90 times 3 is 270 degrees, plus the size of the fourth angle that is actually angle DMO. In total, they must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. We subtracted 270 degrees from this equation and found out that the missing angle DMO, this angle equals to 90 degrees. Okay, so after we found out that inside quadrilateral BCOM we have 4 right angles. And any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. So we relate to quadrilateral BCOM as a rectangle. And we also know that the opposite sides of a rectangle are equal to each other. That is to say, the opposite sides of rectangle BCOM must be equal to each other. That is to say, BC must be equal to side OM. BC must be equal to side OM. But here, according to what is given as the equation, BC equals to 9 units. Here, BC equals to 9 units. And from this equation, 9 equals to BC equals to OM. We will derive that side OM is also equals to 9 units. Here, side OM also equals to 9 units. And here, it is given as the equation that CD is a straight line. And when we extended the straight line CD by a straight line, we got line segment CM. And when you extend the straight line by a straight line, the result must be a straight line, therefore CM must be a straight line. So here, CM is a straight line, and we have the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So if you focus on this side of the straight line CM at point D, here the sum of the angles must be equal to 180 degrees according to rule number 3. So which angles we have at this side of CM at point D? We have here 90 degrees plus this angle, that is angle ADM. So here 90 degrees plus angle ADM, in total they must be equal to 180 degrees according to rule number 3. We subtracted from this equation 90 degrees and found out that the missing angle LDM, this angle equals to 180 degrees minus 20 degrees, it is equal to 90 degrees. So this angle is a right angle. Likewise, OF is the radius of the quarter circle, therefore it is absolutely a straight line. So if you focus on the upper side of the straight line OF at point M, here the sum of the angles must be equal to 180 degrees according to rule number 3. Which angles we have on the upper side of OF at point M? We have here this angle that is equal to 90 degrees plus this angle that is angle DMF. In total, the sum of those two angles must be equal to 180 degrees according to rule number 3. I'll repeat again, 90 degrees plus the size of angle DMF must be equal to 180 degrees according to rule number 3. We subtracted 90 degrees from this equation and found out that the missing angle DMF equals to 90 degrees. So this angle DMF equals to 90 degrees. Then from point L we draw perpendicular on OF. So this angle equals to 90 degrees according to our construction. we define the touching point of the perpendicular from point N and OF as N. So here, by doing this construction, we created quadrilateral LDMN. And inside quadrilateral LDMN, we have 1, 2 free right angles. Okay? And so here, inside quadrilateral LDMN, we have free right angles. The sum of free right angles is 270 degrees plus the size of the fourth angle, that is actually this angle, angle DLN. In total, the sum of those four angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Here we subtracted 270 degrees from this equation and we found out that the missing angle LDN, this angle equals to 90 degrees. So we have actually found out that inside quadrilateral LDMN we have 4 right angles. And any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. So we will relate to quadrilateral DLMN as a rectangle. And we also know that the opposite sides of a rectangle are equal to each other. This is to say the opposite sides of rectangle DLMN must be equal to each other. That is to say side DL must be equal to side MN. DL equal to MN. According to the order, the opposite sides of a rectangle are equal to each other. But according to what is given as the equation, dn equals to 12 units. Here, dn equals to 12. So we can write here that dn equals to 12, and from this equation, 12 equals to dn equals to mn. We will derive that mn is also equals to 12 units. Here, mn is also equals to 12 units. Then we define side dm as 8, and according to the same rule that the opposite sides of everything are equal to each other, we get that dm equals to ln. dm equals to ln. dm equals to ln. But according to our definition, dm equals to h. So can I write that dm equals to h, and for this equation h equals to dm equals to ln, we will derive that ln is also equals to h. Here ln is also equals to h. Okay, so here we join point C and O by a straight line. Point O is the center of the quarter circle. Point C is the point of the quarter circle itself. Therefore, OC is the radius of the quarter circle, that is equal to R. Then we implemented the Pythagoras theorem on the right green triangle, triangle COM. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the square of the perpendiculars. That is to say, CO square equals to OM square plus CM square. Again, OC square equals to OM square plus CM square. OC equals to R, therefore OC square is R square. OM equals to 9, therefore OM square is 9 square, that is 81. And what is the value of CM? CM equals to CD plus DM. That is to say, CM equals to CD, that is 16, plus DM, that is 8. So in total, CM equals to 16 plus H. So if CM equals to 16 plus H, it means that CM square equals to 16 plus H square. Then we open the brackets on this side of equation number 1 and found out that R square equals to 81 plus 16 plus H square. 16 plus H square equals to 16 square, that is 256 plus H square plus 2 times 16, that is 32, times H is 32H. 81 plus 256 is 337, so according to equation number 1, we found out that R square equals to 337 plus H square plus 32H. Then we join points O and M together by a straight line. Point O is the center of the quarter circle. Point L is the point of the quarter circle itself. Therefore, OL is the radius of the quarter circle, that is equal to R. Then we implemented the Pythagoras theorem on the right orange triangle, triangle OLN. According to the Pythagoras theorem, OL square equals to LN square plus NO square. Repeat again. In the right triangle, triangle LNO, OS square equals to LN square plus NO square. OL equals to R, therefore OL square is R square, and it is equal to LN. LN equals to H, therefore LN square is H square plus NO square. NO equals to OM plus MN, that is to say ON equals to OM, that is 9, plus MN, that is 12. 9 plus 12 is 21. So ON equals to 21, therefore ON square is 21 square. So in conclusion, we found out that R square equals to H square plus 21 square. 21 square is 441. So in conclusion, we found out that according to equation number 2, r squared equals to h squared plus 441. Then we created, so we have two different expressions for r squared, therefore we created equation number 4 therefore we created equation number 2 that states that r squared according to equation number 1 must be equal to r squared according to equation number 2. So r squared according to equation number 1 equals to 337 plus h squared plus 32h. And it must be equal to r squared according to equation number 2 that is equal to h squared plus 441. Here we have h squared on both sides of equation number 3, so we will cancel h squared. What is left from equation number 3 after we cancel and h squared? In this side of the equation we have 337 plus 32h. That is equal to 441. Here we subtracted 337 from this equation number 3, and we found out that 32h equals to 441 minus 337, it is equal to 104. So according to equation number 3, we found out that 32h equals to 104. Here we divided this equation number 3 by 32, and we found out that h equals to 104 over 32, that is 3.25. So in conclusion, we found out that h equals to 3.25 units, therefore we can substitute h in equation number 2 by 3.25. According to equation number 2, r squared equals to h squared plus 441. So if h equals to 3.25, it means that h squared equals to 3.25 squared, that is 10.5625. So in conclusion, we found out that according to equation number 2, r squared equals to 2.5625 plus 441. And 441 plus 10.5625 equals to 451.5625. So in conclusion, we found out that r squared equals to 451.5625. We took out of this equation number 1, and we found out that r, the radius that we are looking for, the radius of the quarter circle, equals to the square root of 351.5625. That is equal to 21.25 units. So here we found out that the radius of this quarter circle equals to 21.25 units. That is a little bit, that is longer than line segment ON, that is equal to 21 units in 0.25 units. We finished with the first question, then I presented to you the second question, and we solved the second question in two different methods. According to the first method, here we have triangle ABC, side AB equals to x plus y, side AC equals to y, side DC equals to x, this angle equals to 40 degrees, this angle equals to 80 degrees, and our mission is to find out the size of this angle and angle theta. So in the first method, we did the construction, we extended side BC by a straight line in such a way that CE will be equal to y units. So CE equals to y units according to our construction. Then we join points A and D together by a straight line, and then I copy triangle ACE in this new page, and we analyze triangle ACE. This is triangle ACE that I copied from the original drawing. Here side C equals to y units according to our construction, side AC equals to y units according to what is given as the question. So those two sides are both equal to y, therefore they are equal to each other. That is to say, side AC equals to side AE equals to y, and we have the rule that in front of equal sides in the triangle, there are equal angles. So those two angles that are located in front of the equal sides must be equal to each other. So if one angle is alpha, then the other angle must be equal to alpha. So those two angles must be equal to alpha, both of them. Then I copied angle ACB from the original drawing, and we know according to what is given as the equation, angle ACB equals to 40 degrees. Then I presented to you the exterior angle theorem. The exterior angle theorem is true in any triangle. So here we have triangle ABC with angles alpha, beta, and gamma. Angles alpha, beta, and gamma are defined as an interior angles, while this angle ACD, that is defined as angle E, is defined as an exterior angle. Why? Because it is located outside triangle ABC. So what is the size of the exterior angle, angle ACE, that is equal to E? So the size of this angle, angle E, equals to the sum of the two interior angles that are not adjacent to it. This angle gamma is adjacent to it, and the two other interior angles that are not adjacent to it are alpha and beta. Therefore, the size of angle E equals to alpha plus beta. Then we implemented the exterior angle theorem in this triangle, triangle ACE. Angle ACB is the exterior angle, and those two angles alpha and alpha are defined as the interior angles because they are located inside triangle ACE. So what is the size of the exterior angle, angle ACB? According to the exterior angle theorem, we get that the size of angle ACB equals to the sum of the two interior angles that are not adjacent to it. This angle is adjacent to the angle ACB. The two other angles that are not adjacent to it are alpha and alpha. Therefore, the size of the exterior angle, angle ACB equals to alpha plus alpha, that is 2 alpha. But according to what is given as a equation, the size of angle ACB equals to 40 degrees. So from this long equation, 40 degrees equals to angle ACB equals to alpha plus alpha equals to 2 alpha, we will derive that 40 degrees equals to 2 alpha. We divided this equation by 2 and found out that alpha equals to 20 degrees. So here, this angle, angle CAE, that is equal to alpha equals to 20 degrees, and this angle, angle AEC, that is also equals to alpha equals to 20 degrees. Okay, then we focus on triangle ADC. This angle equals to 80 degrees, this angle equals to 40 degrees. 80 degrees plus 40 degrees is 120 degrees. That is the sum of those two angles in triangle ADC. Therefore, this the third angle must be equal to 60 degrees. Why? Because 60 degrees plus 120 degrees is 180 degrees. And we know that the sum of the angles in any triangle is 180 degrees. So this angle must be equal to 60 degrees. Then I copied triangle ADE in a new page and we analyze triangle ADE. So this is triangle ADE. Then I copied from the original drawing. Here, this angle, angle DAE equals to 20 degrees plus 60 degrees, that is 80 degrees. This angle equals to 80 degrees according to what is given as the question. What is the size of side DE? DE equals to DC plus CE. Again, DE equals to DC plus CE, that is to say DE equals to DC, that is X, plus CE, that is Y. In conclusion, DE equals to X plus Y. So we can write here that DE equals to X plus Y. So in triangle ADE, those two angles are both equal to 80 degrees, therefore they are equal to each other. And we have the rule that in front of equal angles in the triangle, there are equal sides. In front of this angle, we have side DE. In front of this angle, we have side AE. And those two sides must be equal to each other. Why? Because they are located in front of equal angles. So here side DE must be equal to side AE. But according to what we have already found out, DE equals to X plus Y. So we can write here that DE equals to X plus Y. And from this equation, X plus Y equals to D equals to AE, we will derive that AE is also equals to X plus Y. Okay, then I copy triangle ABE in this new page and analyze triangle ABE. Side AB equals to X plus Y according to what is given as the question. We just right now found out that side AE equals to X plus Y. This angle equals to 20 degrees according to what is given as, according to what we have already found out, that this angle equals to theta according to what is given as the question. So in triangle ABE, those two sides are both equal to X plus Y, therefore they are equal to each other. That is to say, side AB equals to side AE. And we have the rule that in front of equal sides in the triangle, there are equal angles. In front of this side, we have side 20 degrees, and in front of this side, side AE, we have theta. And according to the rule that we mentioned, those two angles must be equal to each other because they are located in front of equal sides. That is to say, angle theta equals to 20 degrees. Okay, then I presented to you the second method. In the second method, we focused on triangle ADC. This angle equals to 80 degrees, this angle equals to 40 degrees. 80 degrees plus 40 degrees is 120 degrees, so the sum of two angles in triangle ABC is 120 degrees, therefore the third angle must be equal to 60 degrees. Why? Because 60 degrees plus 120 degrees equals to 180 degrees, that is the sum of the angles in any triangle. So this angle must be equal to 60 degrees. Then I presented to you the law of sines, and we implemented the law of sines on the green triangle and the orange triangle also. What is the law of sines? The law of sines is true in any triangle. So here we have a triangle ABC that would be an A triangle, side AC equals to 3 units, side AB equals to B units, and BC equals to A units in its length. The size of angle BAC is capital A degrees, the side of angle ABC is capital B degrees, and the side of angle ACB is capital C degrees. And according to the law of sines, we get that A over sine A equals to B over sine B equals to C over sine C. Then we implemented the law of sines in the green triangle, triangle ADC. According to the law of sines, in the green triangle, triangle ADC, DC over sinus 60 degrees equals to AD over sinus 40 degrees equals to AC over sinus 80 degrees. DC equals to X, so we substitute DC by X, AD equals to H, so we substitute AD by A, and AC equals to X, and AC equals to Y, AC equals to Y, so we substitute AC by Y. And we got this equation. We have three expressions that are all equal to each other, therefore we can define the value of them as K. Then from this long equation we derive the third equation, that those two expressions are equal to each other. That is to say, X over sinus 60 degrees equals to K. Here we multiply this equation, equation number 1, by sinus 60 degrees, and found out that X equals to K times sinus 60 degrees. We also know that those two expressions are equal to each other, that is to say, A over sinus 40 degrees equals to K. We multiply the equation number 1 by sinus 40 degrees, and found out that A equals to K times sinus 40 degrees. And here, and finally, those two expressions are also equal to each other. That is to say, Y over sinus 80 degrees equals to K. We multiplied equation number 3 by sinus 80 degrees, and found out that Y equals to K times sinus 80 degrees. So we have three expressions for X, Y, and A. Then we implemented, but before that we found out the value, the size of angle ADB. BC is a straight line, so if we focus on the upper side of the straight line BC, we have this at point D, we have this angle that is equal to 80 degrees plus this angle, in total it must be equal to 180 degrees, so this angle must be equal to 100 degrees in order to complete the sum of the angles of the upper side of BC at point D to 180 degrees. This angle must be equal to 100 degrees. Okay, then we implemented the law of sines in the orange triangle, triangle ABD. According to the law of sines in triangle ABD, here AB over sinus 100 degrees equals to AD over sinus theta. Okay, here in triangle ABD, here triangle ABD is here, and I repeat again, AD over sinus theta equals to AB over sinus 100 degrees. Again, AD over sinus theta equals to AB over sinus 100 degrees. AD equals to A, so we substitute AD by A. AB equals to X plus Y, so we substitute AB by X plus Y. A equals to K times sinus 40 degrees, so we substitute A by K times sinus 40 degrees. X equals to K times 60 degrees, so we substitute X by K times sinus 60 degrees. And Y equals to K times sinus 80 degrees, so we substitute Y by K times sinus 80 degrees. We got this equation. We have K on both sides of the equation, so K will get cancelled. What is left from equation number 2 after we cancel K? What is left is that sinus 40 degrees over sinus theta equals to sinus 60 degrees plus sinus 80 degrees over sinus 100 degrees. Then we first multiplied this equation number 2 and found out that according to equation number 2, sinus 40 degrees times sinus 100 degrees equals to sinus theta times sinus 80 degrees plus sinus 60 degrees. We divided this equation number 2 by sinus 80 degrees plus sinus 60 degrees and found out that sinus theta equals to sinus 40 degrees times sinus 100 degrees over sinus 80 degrees plus sinus 60 degrees. Then we have this first trigonometric identity. That sinus 2a equals to 2 sinus a cosine a. We use this trigonometric identity for the value of sinus 40 degrees. Sinus 40 degrees equals to sinus 2 times 20 degrees. And according to this trigonometric identity, it will be 2 sinus 2 times 20 degrees equals to 2 times sinus 20 degrees times cosine 20 degrees. That is to say, sinus 40 degrees equals to 2 times sinus 20 degrees times cosine 20 degrees. Then we have the trigonometric identity that sinus 90 degrees plus theta equals to cosine theta. We use this trigonometric identity for sinus 100 degrees. Sinus 100 degrees equals to sinus 90 degrees plus 10 degrees. And according to this trigonometric identity, sinus 90 degrees plus theta equals to cosine theta. We'll get that sinus 90 degrees plus theta will be equal to cosine theta according to this trigonometric identity. So in conclusion, we found out that sinus 100 degrees equals to cosine theta. Therefore, we substituted sinus 100 degrees in equation number 2 by cosine 10 degrees, and we substituted sinus 40 degrees by 2 times sinus 20 degrees times cosine 20 degrees in equation number 2. And found out that sinus theta equals to 2 times sinus 20 degrees times cosine 20 degrees times cosine theta over sinus 80 degrees plus sinus 60 degrees. And we have the trigonometric identity that sinus d plus sinus c equals to 2 times sinus d plus c over 2 times cosine d minus c over 2. According to this trigonometric identity, sinus 80 degrees plus sinus 60 degrees will be equals to 2 times sinus d plus c. D is 80, c is 60, 80 plus 60 is 140, and 140 over 2 is 70. So it is 70 degrees times cosine d minus c. D is 80, c is 60, so 80 minus 60 is 20, and 20 over 2 is 10. So in conclusion, found out that sinus 80 degrees plus sinus 60 degrees equals to 2 times sinus 70 degrees times cosine 10 degrees. Therefore, we can substitute sinus 80 degrees plus sinus 60 degrees in equation number 2 here by 2 times sinus 70 degrees times cosine 10 degrees. We did it, and we got that according to equation number 2, sinus theta equals to 2 times sinus 20 degrees times cosine 20 degrees times cosine 10 degrees over 2 times sinus 70 degrees times cosine 10 degrees. We have cosine 10 degrees in the numerator and cosine 10 degrees in the denominator, so cosine 10 degrees will get cancelled. We have 2 in the numerator and 2 in the denominator, so 2 also will get cancelled. So what is left from equation number 2 after we cancel those two expressions? What is left? It is actually sinus theta equals to sinus 20 degrees times cosine 20 degrees over sinus 70 degrees. And we have the last trigonometric identity that sinus 90 degrees minus theta equals to cosine theta. We use this trigonometric identity for sinus 70 degrees. Sinus 70 degrees is equal to sinus 90 degrees minus 20 degrees. And according to this trigonometric identity, sinus 90 degrees minus theta is equal to cosine theta. We get that sinus 90 degrees minus 20 degrees is equal to cosine 20 degrees according to this trigonometric identity. So in conclusion, we found out that sinus 70 degrees equals to cosine 20 degrees. Therefore, we can substitute sinus 70 degrees in equation number 2 by cosine 20 degrees. We did it, and we got that according to equation number 2, sinus theta equals to sinus 20 degrees times cosine 20 degrees, and we substituted sinus 70 degrees by cosine 20 degrees. So here we have cosine 20 degrees in the numerator, we have cosine 20 degrees in the denominator, so cosine 20 degrees will get cancelled, and finally we got that sinus theta equals to sinus 20 degrees. And we have the trigonometric identity that if sinus alpha equals to sinus beta, it means that alpha equals to beta. That is to say, if sinus theta equals to sinus 20 degrees, it means that theta equals to 20 degrees. So in both methods, we found out that the size of this angle, angle theta, is equal to 20 degrees. Okay, thank you very much.